Multiplication of radicals. Our objectives: at the end of this presentation, you should be able to multiply radical expression. Let's start. How to multiply radicals? To multiply expressions containing radicals, the product property of square root is applied. That is, the nth root of xy is equal to the nth root of x times the nth root of y. Or in terms, that is, the nth root of the product is the product of the nth root. Example: simplify each expression if possible. Square root of 3 times square root of 18. Unlike in addition or subtraction of radicals, that radicals should be similar terms, which means they should have same indexes and same radicand. In multiplying the radicals, as long as the indexes are similar or the same, we can actually multiply the two radicals. So in this case, they are both square root, so I can multiply them. So multiplying them, we got square root of 3 times 18. Multiplying square root 3 by 18 will give us a product of 54. Now, since 54 can still be simplified, we can simplify it by getting the factor of 54. So the factors of 54 are, we got 1 times 54, we got 2 times 27, and we got 9 times 6. After identifying numbers which are perfect square, we can now identify which of the following factors are perfect square number. Since the only perfect square number that 54 has is 9, so we will be using 9 times 6. So we can rewrite this as square root of 9 times 6. Then simplify the perfect square number inside the radical sign. So the square root of 9 is 3. So we'll be writing 3 outside the radical sign. And what left inside is square root of 6. So the answer is 3 square root of 6. The next example is 3 square root of 2 times 5 square root of 6. So we will be multiplying the numbers outside the radical sign and the numbers inside the radical sign by group. So we got 3 times 5, and the other one is square root of 2 times square root of 6. So multiplying 3 by 5 will give us a product of 15. Then square root of times the square root of 2 times 6 is 12. However, we need first to find for the factors of 12. So the factors of 12 are 1 times 12, 2 times 6, and 3 times 4. So let's identify which of the following factors are perfect square. So the perfect square number is actually 4, so we'll be using 3 and 4. So this will become 15 square root of 3 times 4. And then get the square root of 4 and multiply it outside the radical sign. Number outside the radical sign. So we got 15 times the square root of 4, which is 2. And then just simply copy square root of 3. So we got 15 times 2, we got 30 square root of 3. In multiplying binomials, trinomials, or any polynomials containing radicals by other radicals, the distributive property is used. Example: square root of 2 times the quantity 2 square root of 3 plus 3 square root of 2. So in this case, we will just simply distribute square root of 3 one by one on each of the following terms inside the parentheses. So we got square root of 3 times this 2 square root of 3 plus square root of 3 times 3 square root of 2. So let's simplify one by one. So this will become 2 square root of 3 times 3 plus we got 3 square root of 3 times 2. So simplify the numbers inside the radical sign. So we got 2 square root of 3 times 3, that is 9, plus 3 square root of 3 times 2 is 6. Get the square root of each of the radical. So the square root of 9 is 3. We will be multiplying it to the number outside the radical sign. So we got 2 times 3 plus 3 square root of 6. Since 6 has no factor wherein 1 is a perfect square number, so we will just write it as 6. So we got 2 times 3, we got 6 plus 3 square root of 6. Since we cannot combine 6 and 3 square root of 6 because they are unlike terms, therefore this is now your final answer. We got 6 plus 3 square root of 6. Next example. The quantity square root of 2 plus 3 square root of 5 times the quantity 4 minus square root of 3. So in this example, it is an example of a binomial multiplied by another binomial. Now we can use the parrot-beak method or the FOIL method, but I'll be using the parrot-beak method. So using it, I'll just simply multiply square root of 2 by 4. So we got square root of 2 times positive 4, and then square root of 2 times negative square root of 3, so that is minus square root of 2 times square root of 3, and then 3 square root of 5 times 4, so they are both positive, so that is plus 3 square root of 5 times 4, and then 3 square root of 5 times negative square root of 3, so positive and negative, so that is minus 3 square root of 5 times square root of 3. Now let's multiply one by one. So square root of 2 times 4, so that is simply 4 square root of 2, minus we got 2 times 3, so we got square root of 2 times 3, plus we got 3 square root of 5 times 4, so we will just simply multiply the whole number to the whole number of the given radicals. Okay, so we got 3 times 4, we got 12 square root of 5, and then we got minus, so we got 3 square root of 5 times 3. Then simplify the numbers inside the radical sign. So I'll just simply copy 4 square root of 2 minus we got square root of 6 plus 12 square root of 5 minus 3 square root of 15. As you observe, none of our radicals can still be simplified, and none of our radicals are actually similar. Therefore, our final answer is 4 square root of 2 minus square root of 6 plus 12 square root of 5 minus 3 square root of 15. Next example. The quantity square root of x plus 1 plus 2 squared. So we will be using the square of the binomial. So the rule is we will be square the first term. So we got x plus 1 squared. Then 2 times the first term and 2 times the product of the first term and the last term. So we got 2 times square root of x plus 1 times 2. And the last term will be the square of the last term. So we got 2 squared. Now simplify. So we got a radical raised by an exponent. So we'll be cancelled out the radical. So what left is x plus 1. And then we got 2 times 2, we got 4. So this is 4 times the square root of x plus 1. So that is square root of x plus 1. And then we got 2 squared, that is plus 4. Now let's simplify. So we got 1 plus 4. So this is 4 and this is 1. So we will be combining them. So will give us a sum of 5. So that will become x plus 5 plus 4 square root of x plus 1. Now since we cannot combine 5 by the numerical coefficient of the radical, which is 4, because they are not similar, therefore our final answer is x plus 5 plus 4 square root of x plus 1. If the factors containing radicals have different indices, transform the radicals into fractional exponent, then change the fractional exponents into similar fractions, and then transform to radical form and multiply. So in this case, the indexes is not similar. Therefore, we need to transform the given into similar indexes. So the first step is to transform the given radicals into rational exponents. So we got a cube b raised to 1 over 5 times ab raised to 1/2. The next step is get the LCD of the two given exponent. So we got a cube b raised to, so the LCD is 10, and then divide it by 5 and multiply it by the numerator. So we got 2 raised to 10. So later on I'll be showing you how it becomes 2 over 10, and then the other one is AB raised to 5 over 10. So in simplifying this one, the LCD is actually 10. So the LCD is equal to 10. So we will be dividing 10 by the denominator of original fraction. So we got 10 divided by 5. So this is 2. Then multiply it by the numerator. That's why we got 2 over 10. And then by the LCD, we got 10 divided by 2. We got 5. Then multiply it to the numerator, which is 1. That's why we got 5. So we got 5 over 10. And then transform it again into the radicals. So we got the 10th root of a cube b squared times the 10th root of ab to the 5th power. And then distribute the exponent one by one on each term or each variable on the radicand. So we got the 10th root of a to the 6 b squared, and for this one, this is the 10th root of a to the 5th b. Now we can now multiply or combine them. So we got the 10th root of a to the 6 b squared. So we will just simply multiply them all, a to the 5th and b. So again, we can only combine or multiply similar terms. So in multiplying exponent having the same base, we will just simply copy the base and add the exponent. So we got 10th root of, so we got a to the 6th power times a to the 5th. And we got b to the 2nd power and b to the 5th power. So we'll just simply add the two given exponents and copy the base. So for a, we got 10th root of a to the 11th power. And then for b, we got b to the 7th power. Now since the exponent of a is greater than your index, and we can actually divide 11 by 10, will give us a quotient of 1 with a remainder 1. So we can simplify a raised to 11. So the 10th root of a raised to 11 is a 10th root of the remainder, which is 1. So we got a and then just simply copy b to the 7th power. So the final answer is a to the 10th root of a b to the 7th power. Next example, square root of 8 times the cube root of 12. So again, we need to transform first the given into rational exponents. So this will become 8 raised to 1/2 times 12 raised to 1 over 3. And then get again the LCD and follow the same procedure. So we got 8 raised to 3 over 6 times 12 raised to 2 over 6. So again, the LCD is 6. You divide 6 by the original denominator of the first given exponent. So we got 6 divided by 2, we got 3 times the numerator, which is 1. That's why we got 3. Okay. And then for the second one, we got 6. So we divide 6 by 3, which is 2. Then multiply it by the numerator, which is 1. So we got 2 times 1, we got 2. And then make it again a radical. So we got the 6th root of a cube times the 6th root of 12 squared. Now, since 8 is a perfect cube, we can rewrite this as the 6th root of 2 cube, okay, times the 6th root of, so one of the factor of 12 is actually perfect square, which is 4. So we can rewrite this as 2 squared times 3 squared. Okay. And then we can now combine them. So we got, multiply this 3 by 3, we got 9. So we got the 6th root of 2 to the 9th power. So power by a power times 2 squared, or I mean 2 to the 4th. Because we multiply 2 times 2, we got 4. And then we got 3 squared. So combine similar terms, we got 2 and 2. We got same base, which is 2. Then we just simply add the exponent. So we got the 6th root of 2 raised to the 13th, then times 3 squared. Now, since 13 can be divided by 6, which is actually 2 squared, or 2. So we got 2 squared outside. 6th root of, so the remainder is actually 1. Okay, so we got 2 times 3 squared is 9. So 2 squared is actually 4. Then 6th root of 2 times 9 is 18. So your answer now is 4 6th root of 18. Thank you.